Well, hello everyone, and welcome to a new video. In this video, we are going to talk about IO streams. And to simplify the term, basically, we're going to be talking about how do I read and write from files. Now, let's start with a very simple example here. Imagine that you have a variable, you call it x, and then you ask the user to enter x. And then after that, you're going to print x on the screen. And this is a very simple example here. Your value is, and let's just go ahead and print that on the screen. And line a semicolon. So here we go. This is a very simple project, and I'm just going to show you that enter x, x is 10, so your value is 10. Okay. Now, let's talk about 10 here. What is 10? 10, as you can see, it's a variable. And that variable is going to be stored inside the RAM of your computer system. Now, one of the properties of the RAM system is it's a temporary storage device. And temporary storage device basically means that data and the variables that you're going to create for the program is going to be stored inside the memory as long as there's power in that memory, as long as there's power inside your system. Now, all the data, all the variables that you're going to create, which is going to be stored inside the RAM, will be available in the RAM as long as there is a power inside the RAM and as long as your program is executing. So what does that mean? That basically means if I shut down, if I just turn off my computer system right now, at this moment, X will disappear. I'll have no access to X anymore. Now, if I terminate the program by closing this window, also X will disappear. Why is that? Because the operating system, basically, after you terminate any program, the operating system will go to the memory and wipe out all the data that was used for that memory. Well, not all of them. There are some sort of data was still there, and you're going to be learning about them a long time later. So all the variables that I created now that's stored inside the RAM will disappear and will be wiped out by the operating system the moment the program is terminated. Now, I want you to put in your mind, X is not X. X is patient information. We work at a hospital, we got a new patient, and we created a class for that patient, and we're asking all the information about the patient, his ID, insurance, address, doctor history, all these variables, information that the user will enter using that form that he will be given. Now, those information or those data will be stored inside your program as long as there's an employee using that program. Now, the question is, if that computer lost power all of a sudden, you lose all the data. If that employee decided to turn the computer off and go back home, when he's going to come back next day, again, the data will be lost because it was stored inside the memory. So what do we need to do? We need to find a way how we can save the data. Where can we put the data inside the system so if we terminate the program, the data will be saved, and if we lose power, data will be saved. Now let's go back in time a little bit. And this thing happened to me a long time ago, and I was like, before I get to college or while I was in college, Microsoft Office didn't have an autosave mode. So basically, I used to sit in front of a computer and typing for hours, and all of a sudden, my computer will shut down or restart, and all this hard work was gone. Why was it gone? Because I forgot to do a very simple operation, which is saving my work. Now let's go back to the word saving. What does saving mean? Saving basically means having a copy of the data that you have in your program to be saved into a permanent storage device, which basically a long time ago used to be a hard drive or floppy disk. But these days, it's not a floppy disk. It's not there's no floppy disk anymore. We have a permanent storage device like hard drive SSDs. So the bottom line, when you save your work, you're making a copy of all the data that you have to be saved from the memory all the way to the hard drive or the SSD or the permanent storage device. Let's take another example. You're playing a video game, and then at a certain point you want to leave because somebody's calling you for lunch or something. So what do? You save your progress. What does saving your progress means? Saving your progress basically means you are copying the data of the program at that moment, and you're making a permanent making a copy, and you're storing it in a permanent storage device, which basically is the hard drive in your console or your PC game. So today we're going to learn about how do I actually save my data, which for example is X, inside a file. So when I come back next time, I can have access to X again and use it. Just like if a patient came to the hospital, how do you save his data? And if that patient decided to come back next week for a checkup, you don't have to ask him to enter the information again. Just ask him about his name, and then you can retrieve all the data from the hard drive or the permanent storage device that you have into your system. Before we start talking about reading and writing from files, let's have a look at the cout and the cin here. Both of those terms refer to what we call objects. This is an output object, this is an input object. And the output object, the default output object that we have here, which is what we call cout, has a job of showing whatever you have after the insertion operations into the screen, which is your output device. Cin is your input object, which basically will have you entering values and stored inside X, and your input device in this case will basically be the keyboard. Now, what we're going to try to do today, we're going to learn about how do I change my output device instead of being the screen that you see here to be a file in your computer system, and how do I change the cin to be, instead of reading from the keyboard, to be reading from a file. So that's basically what we're going to be learning about today. For now, I am going to use the same example X here to perform this operation, and then after that we'll go and talk about a little bit more complicated examples. So let's just imagine we have a variable called X, and I will assign 10 to X. My first job is to learn how do I save X into a file. Well, to do that, the first thing you have to do is to import a very, very special header file, and that special header file is called fstream. So include fstream. Now, as you can see here, previously we used to call the file iostream if you want to use cin and cout. Now, since we're going to use files, we're going with fstream. We still need to use the std namespace. Now, let's talk about how do I store X into a file. Well, it's going to go through multiple steps. The first step is to create an object, and this object is basically what we're going to call the output file object. And to do that, let me just make sure that I get the syntax right. One sec. Yep. So the first thing here is to come here and create what we call an ofstream. That's the name of the class. And then you call it, I'll just call it out. You can call it anything you want, of course, but I'll just go with a simple one, which is out. So this is the first thing you have to do. You have to import the fstream, and fstream by itself includes the ofstream and the iofstream. So both of them. Since we're doing an output right now, we're going to go and use an ofstream object. Now, after that, you need to connect your object to a file that you're going to read from. You're going to write to. So this is extremely important. You have to type the name of the object, which is out, and then after that you type dot open, and the open a parenthesis and you close it, and in this area you have to type the name of the file that you're going to try to write to. So I'm going to say my text dot text. Now there's multiple different files you can create. You can create a data file, DAT. You can create a bin file, BIN. All these files, we call them binary files. Basically, if you create them using those formats, you're not going to be able to see the result. That's why I'm going with the text, so you will actually see the result. So I'm connecting my object out to a file called my text. Now, of course, You can ask the user to specify the file and the location of that file if you want, but let's just keep it simple for now, and we're going to just type, this is the file that I want my object to be connected to. Right after that, all you have to do, just like you did cout, let's just go ahead and type a cout. If I want to show X on the screen, what do? Something like that, right? Now, instead of cout, I'm just going to use out, which is the name of my object, and I don't think I need the end line. I'll just keep it simple that way. So this is me using that object. Now, one of the steps that everybody forget about is to terminate this object, which is out.close. This is very important, and you have to do it. Otherwise, again, you're not going to get any errors, but it's against memory management. You need to actually terminate that object. Now, look what is going to happen now. I am going to run the program, and you will not see anything. And here we go. Nothing. You don't see anything. Now the question is, where's X and where is this file? Well, this is very important to understand here. You see here, this is your Solution Explorer. If you go to the name of the project at the top here, and you click on it, right click, and you go open folder, it will take you here. Oh, do you see what I'm pointing at here? My text file, text.txt. Open it. And what do you see here? 10. And that's basically how it works. Now let's go ahead and talk about a little bit of details here. If this file doesn't exist in your folder, and that basically was the case when I created the project, I didn't go ahead and create that file, the operating system will create the file for you. So that's a good news for you. If the file doesn't exist, the operating system will create it for you. Now let me run it again. Okay, let's go back to the folder again. And let's open it again. And you see I got 10 here again. Okay, let me close this one, minimize this one, and let's put 100 here. And let me run it. Again, you don't see anything, but let's go back to the folder and open it. And look what I have here. I have 100. Now you may wonder what happened to the 10. Well, here's what happened to the 10. When the compiler will execute these statements, if the file already exists, the compiler will create a new one and delete the old one. So basically what happened, the one that has to have the 10 value was deleted and the new file was created, which has the same name. Now, what if I want to keep the value of 10 and add 1 to it? This is something we're going to talk about later. But for now, we'll just simplify it as you can see here. So if I want to talk about how do I actually write data to a file, and I'm talking about a simple file here, simple variable, you just basically have to include an OF stream. You have to create an object, OF stream. You have to connect your object to a file. Then you perform the operations of writing the data to a file, and then you have to close that object. Now, what can I type inside that file? Well, it doesn't have to be just X. Here's what I can do. This is the value. This is the value of X. And I can come here and put end line if I want. And I could come here and say out again, test, test, test. And I'll just put the date of today, 6/24/2020. I'll put \n to go to the next line, or I can take it out if I want. Let's keep it simple that way. Now let me save it. Let me run it. And here we go. Now if I go back to the file, you'll see this is the value of 100 test 6/24/2020. So as you can see here now, even if I turn my computer off and come back tomorrow, I have the file stored as a text file, so I can have access to those data if I need them. Now the question is, what if I want to read whatever I have there? Well, this is where it gets a little bit more complicated. Number one, it's not recommended to store messages on those text files. You only want to store data. So what I'm going to do, I am going to take all this away. I'm just going to put X to be stored in that file. Now what I want to do, I want to read X from the file. So I'm going to come here and say integer. Let's call it Y this time. And I want to read that 100 value from the file and put it inside y. So to do that, we're going to basically follow something very similar to those steps. Step number one, you still need to have the f stream, but this time I'm going to create this if stream object, and then I will call it in, and I'll close that, and then I will have to connect in to a file. Now this is a little bit critical. And before I continue, just again, I always forget about this, so I will just go ahead and do it here, close. Now, what do you have to type here? You have to type the name of the file, and it has to be the exact same, not the exact same as this one, but the file that you're trying to read from, you have to type it exactly as it is. So copy this and put it here. Now the question is, what if the name didn't match, for example, like this? The program is going to crash and it's going to throw an error. It's going to tell you that the file that you're trying to read from doesn't exist. Now here's the difference. When you try to write to a file that doesn't exist, the operating system will create it for you. But when you try to read from a file that doesn't exist, the computer will not do anything. Basically, it's going to throw an error and you will have to fix that. So I'm just going to assume at this moment that you're not going to make any of those mistakes. So let's go ahead and see what we can do here. How do I read from that file? Well, just like we did with the cout, I'll just go ahead and do, if I want to read from a file, what do I do? Read from the keyboard. I'll just type it this way. CNY. The user is going to enter something. He's going to enter. Now, instead of that, just like we did before, use this object to read the data from that file. Now, here's the thing. You should understand this. I simply assume that that file contains only one line, one value. If that file contains multiple values, that's a different story. But for now, we're just trying to go through the concept of how do I read and write from a file. Now remember, what I'm going to do here, I'm going to come here and say cout, and let's just put a message here. The value we read from a file is, I'll just put y here, and line, semicolon. Now let's run it. And the value that we read from a file is 100. And let's just go ahead and put a different value, for example, 110. And now just remember, I'm going to open the file. You have 100 now. Let's run it again. And you'll see 110. And if you go back to the file, you basically will see it as 110. So this part, basically, I covered the basics of the basics. How do I write how do I write a single value to a variable, and how do I read that single value from the variable? If we want to actually keep the data that we have in a file every time we run the program and not erasing it and create a new one, there's a trick for that. And to do that, basically, you have to type ios here, ::, and you type app for append. Now, if I run this program, again, you'll not see anything. That's okay. Let's put a value of, let's put 2 here, for example. Run it again. Let's put a value of 22. Let's run it again. And now let's go back and see what happened to the file that we have. Oh, look at this. That's basically what I got. Well, let's imagine that's not exactly what I want. I want them to be separated. So I'll just go save it. So I take everything out. So I need to come here and fix this. I can separate them with a space, or I can separate them with an enter. So I'll go enter end line. And now let's run it again. That's it. Let's put another value. Let's close this and let's put a value, let's say 620. Oops. Okay. And now let's go ahead and check what happened to that file. And you can see here, I got them all in a separated lines. And of course, if you don't want to have it that way, you can come here and put a space instead of end line here. And if you want to take everything you did away, just take this away and run it again. The old file is going to be deleted, a new one will be created. Now, this is basically just for you to know. What I'm going to do now, I'm going to create 3 variables, x1, x2, let's put 100 here, and x3. Well, you know what? Let me just make it a little bit better. What I'm going to come here and say string. We will have a whole chapter to talk about strings later, but I'm just going to say name. And I'll just put my name, for example, or Adam, just to simplify it. And then I will come here and create an integer for age. And let's set that to be, let's say, 6 years old. And then what do we want to do here? We got the name, we got the age. How do I describe that person? Address, string, address. I'll just type USA for simplicity. So I got 3 variables, name, age, address. Since I'm using a string, it's recommended to include the string header file. And there's a reason for that, of course. We're going to talk about that later. Now I do have my object that I created, and I did have open here. That's connected to that file, and then after that I'm going to start entering those values, and I'm going to separate them with a space. So I'm going to come here and say name, and then a space, and then after that we'll go with age, space, and then after that we'll go with address, and then end line. Okay, I got the spaces and everything. So let me run it. And here we go. I am done. Let's go back here, open it, and you can see here Adam6 USA. Let's close that. Do I need to create another variable? Well, yes, let's create another person. Instead of Adam, I'll just put Smith. And he is 16, and he lives in, where does he live? England. And now, since I want to add that, I have to come here and type iOS : app. Now let's run that, and let's close it, and let's go back and check. And here we go, Smith 16, England. I will do another person. Let's call him John. John is 41, and he lives in Malaysia. I forgot how to pronounce this. China. Let's run it again. And if you go back here, open it, and you got, here it is. You got them all stored there. Okay, so this is basically how I store multiple files. And of course, every one of those persons could be a person who came up with an application, and filled the information manually or even using a software, and everything was stored inside this text file. Now what I'm going to do, I am going to come here and comment this section. And this is where it gets a little bit confusing. How do I actually read those values and print them on the screen? Well, here's what we need to do. Whenever you want to read from a file, you need to have a look and have access to the file, so you will see how the data is organized in this file. As you can see here, I know that I have a string, and then I have an integer, and then I have another string. String, integer, a string. String, integer, string. I know, since I'm the one who created the program, I know this is a name, this is an age, this is an address. So I'm going to come here, and I'll create new variables. Let me just copy those. But of course, I'm going to change a little bit. And let me take the Y away. And I was going to say file name, file age, and file address. And of course, I don't have to assign them to anything because I'm going to read from the file. And here we go. I'm reading from the file. Now I need to take this away. Okay, so how do I do that? Well, let me show you the not smart way to do it. What we need to do here is to read those 3 parts. Oh, let's say this, we'll call this a record. I need to read this record, and I need to read this record, and I need to read this record. So what can I do here? I can come here and say in, and then file name. I'll do them all at the same time. And then file age, Control C. And then file address. Put semicolon here. Right after that, I need to show them on the screen. So I am going to copy this. I'm going to change it since I want to show it on the screen. Cout this time. And I have to change those to be insertion operations. Of course, I need to include some spacing here after that. So end line, semicolon. In this area, I need to put space. And do the same thing here. Put a space. Now, since I have 3 of those, I can copy those 3. Oops, I have an extra one here. Control C. And I'm going to put this one here and go down and put that here. Basically, what's going to happen here, as I'm reading from the file, when I read the first record, it's going to be shown on the screen after that. And then after that, I'm using in again. So I'm going to start reading the second record, and then I show it on the screen. And then I'm going to reading the third record, and then show it on screen. And I told you that this is not the smartest way to do it, but here it is. Adam, blah, 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 blah. Okay. Now the question is, this is redundant. I'm repeating the same thing for 3 times. So what we can do, since there's 2 ways to do that. Number 1, and this is again not the smartest way to do it, since I know I have to repeat this for 3 times, well, here it is. For integer I equal 0, and then I is less than 3, using a magic number here, which again is not recommended. I++, and let's put a, and let's go ahead here and close it. Let me reduce the font size here so we can read it. Okay. Now if I run it, here we go. I got the same exact results. Now this totally depends on the fact that I know that I have 3 records. But the question is, what if I don't have records? What if I don't know how many records do I have? Well, here's a trick that you can apply. And there's multiple ways to do that. But I can show you how it works. If I copy, you know what, I'm not going to copy, I'm going to cut this from here and put it instead of, no, wait a minute, I think, yep, this is what I have to do. Change this for loop to be while, and then you put the reading operation inside it. And let's take this one away, the semicolon. So what does that mean? As long as I can read from the file, it's going to be treated, the whole thing is going to be treated as true. The moment you get to the end of the file where there is nothing exists anymore, that's where it's going to be false, and that's where you're going to leave. Let's give this a try. And here you go. So my file could have 3 records, 1,000,000 records. It's still going to work exactly the same. Now, of course, there's another way to answer or to fix this problem, but I'm just showing you all the options. So option number 1, I'm just going to go and read them manually one by one, or I can use a for loop that will go from 1 to 3 in this case. But again, either way, those are not the best way to do it. Now, the best way here to do it is basically to use a while loop and put a condition here. And as long as this condition is true, it's going to keep going with the process. I can use the the in operation to be my Boolean expression. Again, remember we said that before. Anything that's not 0 is treated as as true. So as long as I can read from the file, that's going to be treated as true. The moment you cannot read from the file because you got to the end of it, that's where you're going to leave and you cannot continue. There is another way to read from a file instead of actually having the while loop and having the reading process to be as the Boolean expression here. What I can do, I can cut it from here and put it back the way it was before. And in this area, this is what I'm going to type. I'm going to type n dot EOF, and EOF is a shortcut for end of file. Now, what am I checking here? I'm checking if I got to the end of the file or not. Well, if I get to the end of the file, this is going to be true. So what I need to do, I need to say, as long as I'm not at the end of the file, I want you to do this. You see the idea here? This is where it's a good way to use the not. So the end of file by itself, it checks if I'm at the end of the file. But what I need to do here, I need to continue with the process as long as I am not at the end of the file. And that's why I had to put the end operation. Now, this one has a flaws, of course, and I'm going to show you that flaws in a sec. And I want you to pay attention to the results. And look at this. So I got the first record correctly, the second one, but the third one was duplicated. Now, what is the reason for this duplications? Well, the idea, or the reason for that, is if you go open the file itself, you would notice that this is the first record, second record, third record, and look at this. I do have a space here, which basically contain nothing. So basically what's going to happen is going to show me the result of the last reading operation. So I'll have an extra iteration here. So I need to get rid of that enter. So if I take it out and save the result, this will fix it, of course. So let's go back and run it. And you'll see that it's fixed. Now, where's that enter coming from? Well, it's coming from the part when I was writing the last statement here, which is John 41 China, I added this end line. I was supposed to take that end line away. So basically what I mean here, when you enter multiple users or multiple records in that file, yes, it's a good idea to have them separated by an enter, but the last one should not have that enter because that basically will create another space for a new record, which basically doesn't exist because there could be nothing there. And that's basically how we fix that problem. So I had to manually fix it, of course, by taking that space out. But if you're going to actually write to a file, just make sure you don't have this end line here. Or basically when you start the process, when you start adding multiple records, make sure the last one doesn't include that end line. Now, one last thing I want to talk about here is what if I come here and type string, and I'll call it file name. Well, I already have the file name here, so let's say my file. What I'm being my file, I want to store this variable there. So I can copy this, or cut it actually, and come here and Control V and assign it, and then all I have to do is say my file. This basically should work perfectly fine. And here we go. Now the question is, what if I want to ask the user to enter the value? So I'm going to come here, enter that value. So I'm going to say cout enter, the file name you want to read from. Put a semi-space here, semicolon here. Right after that, I will say cn, and I'll say my file. And then I'll put, I've already put it there. So here's what I need to do. Now look at what I'm going to do. Just remember, I should write the exact same name of the file. Let's just run it now and show you what's going to happen. Now he's asking me about the file name. Now just remember, I have to type. It's a case sensitive, so pay attention to that. .text. And here we go. I got no problem. Now the question is, what if I made a mistake? My text. .text. It worked. Well, actually, it's not a case sensitive. My bad. I think operating system was able to manage it. Now let me just write a file that actually is not. For example, something like that. Oh, look at this. That's a weird action. Okay. So you write a different file. Basically, you'll end up having an infinite loop that will show you values that do not make any sense. So how do I fix this? I want to make sure that I will just enter the right value. Here's what we're going to do. We're going to come in this area after you connect your object to the file, to the file. You type if, and this is extremely important. And I will come here and type else. And I'm going to go here and close it. So what do I put in this system? Well, in dot fail. So if my opening statement was failing to read the file because I mistakenly write the wrong, this is what I'm going to see out. I'll just type file name does not exist. Program will be terminated. Put a \n, semicolon. So what's going to happen here, if I mistakenly typed a wrong name for the file, I'm going to see this message, and then this will not be executed, and the program will just terminate it. Or this is just extra, exit, and put 1. There's exit 0, there's exit 1. Let me just put exit, comment, exit 0. Exit 1 and exit 0. Exit 0 basically means the program was terminated with no problems. Exit 1 basically means the program was terminated due to an error. This is just a way for you to tell the operating system that something went wrong. And then the operating system should have its own protocol to handle those exit 1 and exit 0 thing. So, of course, if I'm going to do it this way, I'm not going to be able to see anything on the screen. So I need to have a get character holder. Now let's give this a try. Remember, I'm going to type something that, let's go my text and text, and you'll see it works just perfectly fine. Now I'm going to type something rubbish. And here we go. Blah, blah, blah. Doesn't exist. Program will be terminated.